Hi guys, and welcome back to another video. So in this video we will be discussing the Rutherford scattering formula. In the previous video we talked about how Rutherford was able to derive a nuclear model of atom based on the conclusions of the Geiger-Marston experiment. Just to show you guys, the nuclear model of atom looked like this. So there was a positively charged dense nucleus in the center of the atom and electrons were orbiting the positively charged nucleus, right? So this was the nuclear model of atom. Now, based on the nuclear model of atom, Rutherford obtained his scattering formula, through which he determined the number of alpha particles per unit area that were reaching the screen at a scattering angle of theta, or any given scattering angle. So I've extracted this formula right from the Arthur Beiser book, which is a very good resource if you're taking university level modern physics in your freshman or sophomore. So I would want you guys to pause the video for a minute and give a look to the formula before I start explaining everything one by one. Okay, so I suppose that you've given a look to the formula itself. Now let's start discussing each and every quantity that has been mentioned, what each variable is representing here. So n theta, first of all, n which is a function of theta, it basically represents the number of alpha particles per unit area that reach the screen at a scattering angle of theta. So what does it mean? Now this was let's say this was my lead collinator, which I told you is a lead screen with a small hole that helps you to direct the alpha particles towards the gold foil, right? So once it has been directed to the gold foil, the particles are going to deflect at different angles when they reach the zinc sulfide coated screen. So the n theta is basically going to represent k at a given angle theta. Let's say what could it be? Let's say at 80 degrees, okay, how many alpha particles per unit area are reaching the screen. Okay, I hope you've gotten it. Let's say this is the normal. So at 80 degrees, let's suppose how many alpha particles per unit area are reaching the screen at the scattering angle of theta. 80 degrees पे कौन से पार्टिकल, कितने पार्टिकल्स जो हैं पर यूनिट एरिया स्क्रीन को रीच कर रहे हैं. Now moving on to Ni, which you can see over here and here. So Ni is basically representing the total number of alpha particles that are reaching the screen. Now this is your screen. I have told you that some of the particles will reflect back, some will be reaching the screen straight after passing straight through the foil, some will be deflected at the angle. Now the amount of alpha particles which will be reaching the screen is going to represent Ni. Okay, so these are going to combine all the alpha particles which are being able to reach the screen at different angles. But you will not be considering the alpha particles that reflected in the opposite direction, okay, or which deflected in the opposite direction. N is obviously the number of atoms per unit volume in your foil. This was your foil, and the number of gold atoms, okay, the number of atoms per unit volume. You will find out the volume of your foil by applying simple formula for finding the volume of a cuboid, and then you will be finding out the total number of atoms, okay, that were there in that foil, and then you will be dividing it with your volume to get the total to get the number of atoms per unit volume in the foil, okay. Then Z here, I'm sorry, this has been erased, sorry, this has been like hidden under the green pen. So Z, and where else is Z? Z is here, Z square, right? So Z is representing the atomic number of the foil atoms. For example, if there was gold, you have to write the atomic number for gold. If let's say there was sodium, then you will write the atomic number for sodium, and vice versa. So R here is representing the distance of the screen from the foil. So this is your foil, this blue thing is your foil, and this is your zinc sulfide screen, and the distance between the two, I'm sorry this is getting very messy, but so the distance between your foil and your screen is being represented by R, okay, and R is right here. And then finally you have Ke, which is the kinetic energy of your alpha particles, which were being accelerated from a given radioactive source. You can easily determine that. And then T is the foil thickness. Okay, the thickness of your foil. If you're using gold foil, uski kya thickness thi, and vice versa, right? So this is it for the Rutherford scattering formula. Now I will be showing you a very interesting graph, and here it is. So this is going to show you the scattering that is taking place at different angles. And you can observe how at approximately 60 degrees, we have like a lot of atoms that are, we have a lot of atoms that have deflected at 60 degrees, and eventually it is decreasing. So Rutherford scattering, now n theta is the number of alpha particles per unit area that reach the screen at angle theta. N 180 is the number for backward scattering. I'll erase this and show it to you. It was once again hidden. Let's change this to a yellow. So n theta are the number of alpha particles per unit area which are reaching the screen at the scattering angle of theta. And n 180 is the number of alpha particles scattering that are going backwards. The experimental findings follow this curve, which is based on the nuclear model of atom. The nuclear model of atom, ये जो nuclear word use होता है, it basically means कि the model of atom consists of the concept of nucleus. Earlier on, when people were following J.J. Thomson's model, it lacked a nucleus. In fact, it supposed that there is a whole positively charged mass with electrons embedded in it, right? Like a fruit cake. Now the predictions of this equation 4.1, it is 4.1 as labeled in the Arthur Beiser book. So according to the predictions of 4.1, they agree with the measurements of Giger and Marsden, which supported the hypothesis of a nuclear atom. This is why Rutherford is, credited with the discovery of a nucleus, because he used those conclusions by Giger and Marsden and he came up with the idea of the nucleus. Also notice that n theta is inversely proportional to, wait a minute. Yeah, so here notice how n theta is inversely proportional to this, right? Pause it and observe it. Now the variation of n theta with theta is very pronounced, okay? This is what it means. According to the graph, in fact, only 0.14% of the incident alpha particles are scattered by more than 1 degrees, which means most of them were able to pass straight through and reach the end of the screen. So this is it for today's video. I'm sorry if I've made a mistake. If I've made a mistake, you guys can comment down and let me know if you guys found the video to be helpful. In the next part, we will be discussing about nuclear dimensions, and it is also a part of 4.1 Arthur Beiser. Thank you so much.